Assalamu alaikum. Today's video is related to current electricity. In today's video, we will learn about some fundamental quantities related to electricity. And these quantities are EMF and potential difference. We will study about the difference between them. We will know what is an EMF and what is the potential difference. And we will also study about open and closed circuit in today's video and electric current. So let us start. First, we will study some symbols. The first symbol is battery. Battery is a collection of cells. This is single cell, two or more cells joined to form battery. So shorter line, short and thick line shows negative terminal of the battery. Long line shows positive terminal of the battery. So when we connect two batteries, we connect one positive and the other negative. This is the symbol of resistor. This one is bulb. Ammeter. Ammeter measures current. Voltmeter measures the potential difference, and it also measures EMF of the battery. This is a switch. This is diode and thermistor, LDR. In one of the previous videos, the one which was related to electrical resistance, you must have learned about the thermistor and LDR. Fuse, this is discussed in one of the previous videos, that is mains electricity. So it is a safety measure, and this is the variable resistor, which we will use in our later lectures. Now, what is electromotive force? In order to light up the bulb, we need a battery. Battery provides electromotive force. It gives energy to the charges which flow through the bulb, and their energy converts into light energy and heat energy. So electromotive force denoted and measured in volts. It is denoted with EMF, is the electrical action produced by a non-electrical source. Battery is non-electrical. Battery has chemical in it. Okay, so it means it converts non-electrical energy into electrical energy. This is the major difference between electromotive force and the potential difference. Electromotive force converts non-electrical energy into electrical one, like chemical in the battery gives electrical energy to the charges. In the same way, your generator, it has some parts which rotate, so it converts mechanical energy into electrical energy. So mechanical is again non-electrical. So who first found out this term? The name was Alessandro Volta. What he said that there was a force separating the charges in current flowing in a closed circuit. It separates the charge. It does not let the similar opposite charges meet each other. Otherwise, positive and negative charges, they need to combine. They attract. Like and unlike charges. Unlike charges attract. Like charges repel. So battery separates the charges, and he gave them the name force. As a result, his last name is forever attached to the EMF, electromotive force, which separates the charges. Okay, it separates two opposite charges. It does not let opposite charges meet each other. It drives the charges through the external circuit. Okay. It gives the energy to the charges. These charges will flow through the external circuit. I will show you what is the external circuit in the next slide. The electromotive force, or EMF, is the energy provided by a cell or battery per coulomb of charge. Every coulomb of charge which passes through the cell, it gains energy. It is measured in volts, and the name is against the name of the scientist. It is equal to the potential difference across the terminal of the cell when no current is flowing. What does that mean? I will just show you in the next slide. This is the battery across which voltmeter is connected. You remember, our voltmeter is always connected in parallel to the circuit. Okay, so this voltmeter, which is connected across the battery, will show you the EMF of the battery. Even if the switch is not closed, it is open switch. Here the switch is open. So bulb is not glowing, means current is not flowing. So this battery has EMF, and that can be measured by this voltmeter. Just see the previous slide again. The electromotive force is the energy provided by the cell or battery to every coulomb of charge which passes through it, and it is measured in volt. It is equal to the potential difference across the terminal of the cell when no current is flowing. Okay, so there is no current, but the cell will draw its required current from the battery, and it will show the EMF of the battery. Okay, right now switch is open. It's open switch, and it is open circuit. Circuit is not complete. Current is not flowing, but the voltmeter will show the EMF. So it is work done is equal to EMF into charge. EMF is equal to work done per charge, or work done is equal to EMF into charge. W is equal to E into Q. The potential difference is the name, is a measure of how much energy is transferred between 2 points in a circuit. The difference in the potential between 2 points that represents the work involved or energy released in the transfer of a unit quantity of electricity from one point to another point. In the next slide, I will explain the meaning of this. Potential difference, how much energy is transferred when charge passes from one point to another point. Okay, so like when charge passes through the bulb, its electrical energy which was given by battery will convert into light energy. It's also potential difference also has the same formula, energy upon charge, like EMF. EMF is energy given to the charge. Here it is the energy transferred by the charge when it passes through some resistance or bulb. Potential difference is also measured in volt, same formula, energy upon charge. Energy is measured in joule and charge is measured in coulomb. So what is 1 volt? 1 volt is the potential difference when 1 coulomb of charge transfers 1 joule of energy. So it means the potential difference between the 2 points will be 1 volt. V is equal to W over Q. Now this is the circuit. Here voltmeter V1 shows 3 volt, which is the EMF of the battery. Right now switch is open and current is not flowing. Okay, and but voltmeter V1 is showing 3 volt, whereas voltmeter V2, which is connected across the bulb, is showing 0 volt, because right now there is no current through the bulb as the switch is open. So it is an open circuit. So what happens when we close the switch? The current starts flowing and the bulb lights up, and the voltmeter now shows, V2 now shows the potential difference across the bulb. Okay, so this is the 3 volt. Why entire 3 volts are across the bulb? Because there is no other component connected in the circuit. The only component which is connected, which will need, which has some resistance, is bulb. Okay, so bulb is, again I will show, the switch is open, current is not flowing. When the switch is closed, the current starts flowing and bulb lights up and voltmeter shows 3 volt. Earlier this was showing 0 volt. Okay, and this one keeps on showing 3 volt. But usually what happens when a battery has some internal resistance, after the current starts flowing, the battery potential difference will be changed. It will be less than before. But in O-level classes or IGCSE classes, we have to ignore the internal resistance of the battery. Okay. Now, there is one short question. What is the charge flowing through the bulb if the energy transferred is 0.6 joule? So what is the potential difference? 3 volts. So how much charge is flowing through the bulb? We will calculate it using this. V is equal to W over Q. W is energy or work done, and this is charge. So we have to find out how much charge. Potential difference was 3 volt is equal to energy is 0.6 joule over Q. So what is Q equal to? Q is equal to 0.6 divided by 3. So what will be our answer? When we divide 0.6 by 3, we get 0.2. What is the unit? 0.2 coulomb charge will be flowing through the bulb. Now open and close circuit. First circuit here, which is shown through which the current is flowing, the path is complete and bulb is on. It's lighting up. Okay, current flows from the positive terminal of the battery towards the negative terminal of the battery. The arrows, they indicate the direction of flow of conventional current. So it is a closed circuit. The next circuit which is next to it is an open. Why? Because the wire is broken and bulb is not lighting up. Okay, so this is open circuit. So bulb goes off because current does not flow. What does this third circuit show? Right now it is a complete circuit and bulb is lighting up. What happens when we take a wire and we connect it across the lamp, across the bulb? When we connect a wire, what will happen? See, the current stops flowing through the bulb and it chooses an alternate path. This green wire shows the path for the charges to flow. Now the charges are flowing from the positive terminal of the battery through this green wire back to the negative terminal of the battery. They are not passing through the bulb anymore because bulb is offering resistance. It offers resistance. So it is difficult path for the charges to flow. And this is the copper wire, which is the path through which current will flow. It's low resistant path. So we call it short circuit. Okay, so bulb is shorted out. It is not glowing anymore. So what do we call it? Short circuit. Open and closed circuit. So here first circuit is an open circuit. The switch, the key is not inserted. Current is not flowing. Bulb is not lighting up. Okay, the second circuit will show, is showing what? The current is flowing and the bulb is lighting up. A circuit is considered to be a closed circuit when electricity flows from an energy source to the desired point and back to the source. In other words, a closed circuit has a complete path for the current to flow, whereas open circuit does not, which means that the circuit is not functional. Bulb is not lighting up. If any other appliance is connected in place of bulb, that will also not work, like loudspeaker, etc. Current. What is current? It's a rate of flow of electric charge. Okay, when the switch will be closed, what will happen? The current which flows from positive terminal of the battery through the bulb to the negative terminal of the battery, we call it conventional current. And electron current is actually the flow of electron. Okay, so that flows from negative terminal of the battery towards the positive terminal of the battery. So current is equal to charge upon time, Q upon T. And ampere is the unit of current, charge coulomb times second. It means ampere is equal to coulomb per second. There is one more formula, that is from the Ohm's law. Current is equal to potential difference upon resistance. I is equal to V over R. So these all formula we will be using in our next video, that is electricity and DC circuits. We will calculate the quantities which are unknown using these formulae. So this is an electric current. Here the diagram shows the flow of electron current. Okay, that is flowing from negative terminal to the positive terminal. conventional current will be flowing in the opposite direction, that is this way. This red arrow shows the direction of conventional current, that is from positive to the negative terminal of the battery. In our circuits, we will be considering the direction of conventional current. Okay, because this was decided earlier when the flow of electron was not known to the scientist, and they knew that is the current. They thought the current is flow of positive charges, but later on they came to know that the positive charge in an atom cannot leave its place in the solid. The positive charge is an atom which has lost an electron, and those atoms cannot flow in solids. These are the electrons which move. But the effect is same, whether electrons going from negative terminal of the battery towards the positive terminal of the battery, or the direction of conventional current from positive to negative will give you the same effect. That is, the energy will be converted. That is why this idea is not changed. So we still use the idea of conventional current, that is from positive to negative, and other rules are devised on the basis of this concept, that is the concept of conventional current. The rules are applied in magnetism. Okay, so this is all for today. Next video inshallah will be uploaded soon, and that will be related to DC circuit. And till then, Allah Hafiz.